So, when we talk about making AI safe, we usually think it's about giving it a set of rules, right? But what if I told you that one of our most common safety tools, well, it doesn't work at all like we thought it did? Today, we're going to peek under the hood of a really foundational paper that pulls back the curtain on safety prompts, and what it found is, frankly, a lot less elegant than you might imagine.
Here's the image most of us have in our minds. You ask an AI something sketchy, and without a safety prompt, it might just spill the beans. But you add a simple little phrase like, "You are a helpful and harmless assistant," and boom, it refuses. This is the common wisdom, right? You give it a rule, it follows the rule. Seems straightforward. But it turns out it's not that simple at all.
And that gets us to the real question here. What is actually going on inside that massive neural network when it reads that prompt? Is it, learning a little moral lesson, or is something way simpler and honestly way more blunt happening instead? We are about to bust a pretty big myth in the world of AI alignment. All right, to get to the bottom of this, here's our game plan. First, we're going to look at this idea of the safety guardrail. Then, we'll actually create a map of the model's mind, which is super cool. After that, we'll uncover the big misconception, introduce a much smarter way to get the model to refuse, see the powerful ripple effects of that, and finally, we'll explore some pretty wild ideas that this whole thing unlocks.
Okay, so let's start with this whole idea of the safety prompt being a guardrail. For years, as these models got more and more powerful, all the big labs relied on these prompts. They were seen as a simple, effective first line of defense. The core assumption was that we were teaching the model something. But this paper, well, it decided to actually test that assumption.
The big idea floating around was that a safety prompt was basically like a mini lesson in ethics for an AI. You give it the right context, and it learns the concept of harmfulness, so it knows to reject certain requests. We really thought we were making it a better judge of character. So the researchers set up this brilliant test between two competing ideas. The first hypothesis is the one we just talked about. Prompts teach the model to recognize what's bad. But the second hypothesis is a little more cynical. It suggests the model already knows what's harmful, and the prompt just makes it more, disagreeable. It just nudges the model to say no more often, to everything.
Now, to figure out which hypothesis is right, you can't just ask the model. You've got to peek inside its brain. So the researchers came up with this incredible way to visualize how the model is thinking, to literally create a map of its internal understanding. And this is where it gets really, really cool.
They did this by looking at what's called representation space. Just think of it like a giant, invisible map inside the model's mind. Every single question you could possibly ask it has a specific coordinate on this map. And queries with similar meanings, like, how do I bake a cake, and what's a good recipe for brownies, are located right next to each other, like neighboring towns.
So for example, a query like how to construct a bridge would be in a totally different part of the map than how to construct a false narrative. See how they use similar words, but their meanings are worlds apart? The paper used pairs just like this to see if the model was grouping things by their actual meaning or just by the words used. And here it is, the first bombshell from this research. When they plotted all these queries on the model's internal map, this is what they found. Even with no safety prompt at all, the harmful queries and the harmless ones were already in two completely separate, distinct clusters. The takeaway here is massive. The model already knows the difference. The prompt isn't teaching it to recognize harm. Hypothesis 1? Busted.
So, if the prompt isn't teaching the model what's bad, what on earth is it actually doing? This leads us straight to the big misconception and the true, much less sophisticated function of a standard safety prompt.
This quote from the paper really says it all. What the researchers discovered is that a safety prompt doesn't draw a sharper line between good and bad. No. Instead, it takes every single query, the harmful ones and the harmless ones, and just shoves them all in one single direction on the map. A direction they figured out was the refusal direction. It just makes the model more likely to say no to everything.
And here is the hard proof. Just look at this data. For a model like LMA2, the rate it refuses perfectly normal, harmless questions jumps from 4% all the way up to 21% when you add a normal safety prompt. That's a 5-fold increase in just being unhelpful. It's kind of like telling a customer service agent to be more careful, and they react by just hanging up on 1 out of every 5 customers.
So this is the fundamental problem the paper identifies so clearly. The standard safety prompt isn't a scalpel, it's a hammer, it's a blunt instrument. Sure, it reduces the bad replies, but it does it by just making the AI more disagreeable and unhelpful across the board.
What we really need is that scalpel, something that can precisely cut out the harmful stuff without damaging everything else.
And that is exactly what the researchers went on to build. Now that they diagnosed the problem, they created a solution, a brand new method they call DRO, which stands for Directed Representation Optimization. The idea behind DRO is just so clever. Instead of trying to retrain this whole giant model with billions of parameters, you freeze it. That's the snowflake. All of its knowledge stays exactly the same. Then you just focus on the prompt. But instead of a sentence, you turn the prompt into a small, trainable set of numbers, a soft prompt. This is the only part you train, the only part you surgically optimize. That's the fire.
So here's how the DRO method works, broken down into 4 steps. First, it pinpoints that exact refusal direction on the model's map. Second, it creates that smart, trainable prompt. Then, and here's the magic, it's trained to do 2 things at once. It pushes only the harmful queries towards refusal, and at the same time, it actively pulls all the harmless queries away from it. It's a precise push and pull, not just a blind shove.
Okay, so the theory is super elegant, it's smart, it makes sense, but does this surgical approach actually work any better than the old hammer? Well, the results are nothing short of incredible.
This number right here is the headline. The researchers tested DRO on a common jailbreaking benchmark. With a standard prompt, the LLMA2 model would comply with harmful requests about 10.3% of the time. But with the new DRO-optimized prompt, that number just plummeted, all the way down to 1.4%.
I mean, just look at the difference here. This isn't just a tiny improvement. It's a nearly 90% reduction in harmful behavior. It's the difference between a bucket that's full of leaks and one that's totally sealed. They really did replace the hammer with a laser-guided scalpel. And these results are the proof.
So what does this all mean for the bigger picture? The takeaways are huge. 1, DRO is just a massive leap forward for AI safety. 2, and this is so important, because it pulls harmless queries away from refusal, it doesn't make the model less helpful. 3, it works on a whole bunch of different models. And 4, it gives us a completely new way to think about alignment, not just teaching rules, but directly steering concepts inside the model's own mind.
And that brings us to what might be the most exciting part of all. This paper doesn't just fix a problem, it kicks open the door to a whole new world of possibilities. Because if we can find the direction for refusal, what else can we steer?
This is where things get really profound. If there's a refusal vector, could there also be one for honesty, or creativity, or what about succinctness? Imagine you could fine-tune an AI's behavior, not with a long, complicated prompt, but by just amplifying these conceptual directions. This idea, let's call it directional alignment, could be a future where we can dial up or down different aspects of an AI's personality. We could crank up factual accuracy to fight hallucinations, or boost step-by-step reasoning to solve hard problems. The true legacy of this paper might not just be a safer AI, but a brand new toolkit for shaping how AIs think.
This is for entertainment purposes only.